Section 5.2, Finding Theoretical Probabilities. Okay, we've got some probability rules to cover that we're going to use for the rest of this chapter and really for the rest of the semester as well. The first one is that probabilities are always numbers between or including 0 and 1. You can give your answers back as fractions, decimals, or as percents. So another way to say that would be between 0% and 100%. That's important to remember because anytime you're doing a question where you are finding a probability, if you get a number back that is larger than 1 or that is negative, then that cannot be true. That has to be a mistake. You should go back and check your work. Okay, so our extremes are 0 and 1. 0 means it's a probability that it's a probability that can never happen. So my example for that, this is just an example, would be the probability that a person lives on the sun. That can never happen, so that has a probability of 0. Now the alternate extreme to that is the probability that an event always happens. So for me, that one I put probability that a human breathes air. That's a probability of 1. That always happens. So 1 is certain to happen, 0 is absolutely certain to not happen, and then everything else is somewhere in between. Okay, second rule is the probability that an event will not occur is 1 minus the probability that it will occur. Putting that into some notation, that'd be P parentheses, so the probability that A does not occur is 1 minus the probability that A does occur. And this leads us to a definition. Complements are probabilities that add up to 1. We use the symbol A superscript C for A complement. And with that notation, what we're saying is that if we were to find the probability of A complement, we would do 1 minus the probability of A. The third probability rule is, in general, how do we find probabilities of any general event? Well, you take the number of outcomes in the event that you're interested in, and you divide that by the total number of outcomes. So you can set these up as fractions. Okay, so here's our first example. Let's suppose we were to reach into a bowl without looking that has 5 red dice, 3 green dice, and 2 white dice in it. Find the following probabilities. Okay, so our denominator is the total. So the total different dice that we could pick from is 10. And I'm specifically interested here in the probability of pulling out a red one. So 5 out of those 10 are red. If I'm going to give my answer back as a fraction, I have to give it in lowest terms, so that would be 1/2. I could also give this back as 0.5 or as 50%, depending on how they ask for it. Probability of drawing out a green die, still out of the 10 total, is 3 out of the 10. I could give that back as 0.3 or as 30%. Probability of drawing a white die, still out of 10, would be 2. I could give that back as 1/5, 0.2, or 20%. Now notice we've covered all of the possibilities. Those are the only 3 things that could ever happen in this situation. So if we were to add all those probabilities up, we would get 1. Okay, here's another example. It says a couple plans to have 3 children. We want to first give the sample space for this situation, and a sample space is the list of all possible outcomes. Okay, so if a couple is going to have 3 children, let's list all the possibilities that they could have. So they could have 3 boys. They could have any combination of 2 boys and a girl. So they could have boy, boy, girl, boy, girl, boy, or girl, boy, boy. That would be putting the girl in all 3 of the areas there. And then we could have 2 girls and a boy, so that could look like girl, girl, boy, boy, girl, or boy, girl. And then the last option would be 3 girls. So that's my sample space. That's everything that could possibly happen. And there are 8 total possibilities there. So I'm going to be using 8 as my denominator when I'm finding these next probabilities, because that's the total. What's the probability that the family will have 2 boys? Well, out of 8 total possibilities, 2 boys would be this one, and this one. So 3 out of the 8. What's the probability that the middle child is a girl? Okay, let's see. That's this one, this one, this one, and this one. So out of the 8 total, there are 4, and since I can reduce that, I should.